Let's go ahead and get started. Welcome, everybody. Thanks for taking the time to view this presentation. Today, we're going to talk about basically how to choose between hybrid versus native apps. Which approach is the best? Of course, with everything, like with everything else, there are pros and cons to each approach. And so what we're going to do today is look at the pros and the cons of each approach. First, we're going to spend some time looking at hybrid app development, pros and cons of it. Then we're going to look at native app development and look at the pros and cons of this approach. And then we're going to spend a little bit of time on what a modern MEAP, which stands for Mobile Enterprise Application Platform, can do, and which offers the best of both approaches. Okay, so fundamentally, when it comes to building apps, there are two ways you can go, two ways that you can build apps. You can build hybrid apps, or you can build native apps. So let's spend a few minutes on distinguishing between the two. When you're building a hybrid app, what you're essentially doing is you're using HTML, JavaScript technology, which is the same technology that you build websites with, and you are turning this, let's call it a website, into an executable app by using some kind of a wrapper technology. The most popular one being out there is PhoneGap. So you're essentially building a website in HTML5 JavaScript, and you're turning that website into an executable app that you can then download to people's devices, distribute to people's devices, and so on. Right? So this approach is basically a web technology approach. It's exactly the same approach that you would use to build a website, except that here you're building a website and then you're making it executable. Part of this approach is you are taking a browser, your app runs in the browser, then you're taking the app and the browser and you're creating an executable out of it. That's what's called a hybrid app. The other approach is to build a native app. As the name suggests, that's an app that specifically is built for the operating system of a particular device, right? So if it's an Android device, it's an app built using Android SDK, built in Java, which is the native language for programming Android operating system. And in case of iOS, it's Objective-C is the programming language, and you're building this app to Apple iOS SDK to run on iOS devices, iPhone, iPad, and so on. So when you're building a native app, you are building it directly and specifically for the device that you want to support it. You would use native SDKs provided by mobile platform device vendor, and you're creating an app that way. Okay, so those are two sort of approaches that you can use. And as you very often hear and read on the internet, there's quite a bit of almost religious discussion going on between which approach to use, which is the best approach, and people are arguing back and forth, right? So each approach has pros and cons. There is no best way. And from the point of view of Snappy, we support both approaches, so we really don't care. That's why we want to offer you an objective advice so that you can make that decision for yourself. So take a look at the pros of hybrid apps. Probably the biggest pro that hybrid apps have is the fact that you only have to build one app. You build it once, and then it will run on a variety of mobile devices, right? As opposed to when you're building a native app, you have to build an app for each mobile device platform separately. This is build once, run anywhere. Uh, the other big advantage of building a hybrid app is the fact that you are building it using JavaScript, which is now the most popular programming language. So this basically means that a lot of programmers know JavaScript, and finding people to build hybrid apps is a lot easier than finding people to build native apps, more resource available. Um, JavaScript in general tends to be more of a higher level object-oriented language, uh, and is in general easier to program than definitely Objective-C, which is a very low-level programming language, and Java. Um, Java to a lesser extent, but nevertheless, I mean, JavaScript is a language built to program browsers. It tends to be a higher level language. It's interpretive, and from a learning perspective, it's definitely easier to learn than Objective-C. Because you're building one app that runs on all mobile devices, it's ultimately faster and cheaper to build as opposed to building a native app. Right? So these are the key uh, pros for building a hybrid app. And what we see in the marketplace is hybrid apps are especially getting popular with building apps for employees uh, in companies. Of course, hybrid apps have a lot of limitations. Okay, and so let's spend a little bit of time discussing what those limitations are. The one of the biggest limitations is this whole issue of browser fragmentation. The issue is essentially that HTML as a language is not specific enough, and therefore different browsers interpret HTML differently. And since this is not new to mobile, this is exactly if you build web applications, you have the same types of issues. It may look a certain way. Your web app may look a certain way in Internet Explorer, but looks a little different on Chrome. And then maybe in Firefox, that some particular feature doesn't work or is not supported. This has been a fundamental problem with web development for a long time, and it's not any different when you're using this technology to build mobile apps. Rendering is different, so it will look differently on different platforms. Some of the features of HTML5 are supported on some browsers, but are not supported on other browsers, right? So if you are an absolute stickler for to achieve a consistent UI UX experience, you'll find that that's very difficult to do using a hybrid app approach. And then from a programming perspective, while JavaScript may be easier to learn, these apps tend to be difficult to debug because of these cross-platform issues, right? So it may look fine on some browsers, and not okay on another browser. And since you really can't go in and change the code inside the browser, you're constantly having to work around the browser issues. And people in general spend a lot more time debugging issues with uh, with hybrid apps and working around browser limitations, right? And when you build native apps, when you're not dealing with any of the browser limitations at all because you're not using the browser. So the browser fragmentation is a real issue. Debugging apps is a real issue. Another problem that you may run into is a performance problem, right? So when you're building a hybrid app, just think about how many layers of software go into this app. You have your HTML, JavaScript code, which then needs to run in the browser, right? Because that's the hosting environment. Then the browser code needs to call PhoneGap code, the wrapper code, or an equivalent wrapper technology that provides access to platform SDK, which then goes to the operating system. So there's a lot more software that you're executing. And mobile devices, while the CPUs have improved a lot, they still to be pretty slow. So there's a lot more code that needs to be executed. So clearly, this is not an approach when you have something that is very CPU intensive, maybe calculations or graphics, high graphics, video, streaming. I mean, when you have anything that's CPU intensive in an HTML hybrid app is just may not offer the level of performance that you need to have in the apps. And there's been a number of notable cases in the industry. Facebook first did a hybrid app and then decided that wasn't really good enough. More recently, LinkedIn backed away from a hybrid approach and went towards native approach. So really depends on your app requirements. It's very difficult to draw a generalization to say, will my app work adequately fast enough as a hybrid app? The answer is it depends, right? So, um, but these are the kind of the guidelines that we can give you is if your app tends to be more CPU intensive, if it's doing, if it needs to have a multi-threaded architecture that can be retrieving data in the one thread, rendering graphics in another thread, probably want to stay away from a hybrid approach. Hybrid works best for very, fairly simple apps that retrieve data, manipulate data, don't get too fancy in terms of graphics and so on. Another issue that you should be aware of is security issue. So JavaScript being an interpretive language in the browser, from a hacking perspective, offers more opportunity to hack than a native app, which is compiled, which doesn't have the browser and all of its interfaces and surfaces to exploit from a security perspective. So if you are in environments where high security is a must, not that don't misunderstand me. Not that I'm saying that you can build secure applications. You can use secure sockets layer. You can do a lot of security, but in general, native apps will be more secure than web apps. Another limitation of hybrid apps has to do with access to hardware. So again, this is web technology, right? And if you build web apps, not necessarily for mobile, but web apps in general, I mean, you know that browser apps running in the browser are specifically designed to be prevented from accessing hardware, file system, storage. They're designed to basically run inside the browser, right? So when you add something like PhoneGap, which then opens up access to some native APIs and access to hardware and so on, you are doing something that the technology, really the web technology, was not designed for. So you're likely to find limitations in terms of what hardware you can and cannot access. These limitations are the result of a browser that's being used or PhoneGap support for certain APIs. You may find yourself having to extend their APIs with some native code to be able to get at the hardware. So this type of an approach, a hybrid approach, has a number of limitations when it comes to accessing hardware, and you should be aware of those limitations. And if your app relies on or depends on fast access to device hardware, this may not be the right approach for you. The next limitation is, I already kind of mentioned, that it really has to do with differences in browsers and how they render HTML. If you need to achieve a really a native look, you may want to consider building a native app for each platform, because at the end of the day, your app is still not going to look native depending on kind of the browser differences. And then finally, but very important, mobile apps are by their nature people use them in environments that are not just inside companies, right? And the apps oftentimes need to work in disconnected mode, and you need to be able to store data locally on the device. You need to have access to a relational database. Usually SQLite is being used. So in order to be able to build apps that work in a disconnected mode, that have access to local storage, when you're building apps using a hybrid approach, again, this is not what it was designed for. And you can get access to local storage by extending using wrapper code or extending wrapper code with native functionality. But you just keep in mind that's really not what it was designed for. If you have an app that needs to work in a disconnected mode, that needs to have total access to a relational database, oftentimes it's best to use a native app for this approach. Right? So as you can see, a lot of limitations using a hybrid approach. While it has many pluses, it also has a lot of drawbacks. And so these are things that you should consider when you're selecting which way to go. So why native apps, right? I mean, they at the end of the day, they offer best performance possible. Because again, there are a lot less code to execute. Your app is linked with SDK. The runtime environment calls the operating system functions directly. The smallest amount of code, it's going to give you the best performance possible. You can do a lot of things in terms of optimization, multi-threading, and so on. A native app is going to give you the best security as well, because you will have access to direct access to how and when you want to secure, encrypt the data, how the data is encrypted when it's stored. You have a lot more options. You're not working through what's available to you via the browser or the wrapper APIs. With native apps, since they're designed to run natively on a device, and they naturally have total access to local databases and on-device storage. So If it's an app that requires a lot of local storage or a lot of flexibility around access to local storage, native apps would clearly have an advantage there. And same with disconnected mode, right? And this is, by the way, this is one of those issues that they've gotten so used to building apps that rely on the fact that network connection is always there, that people not always kind of think through this. But when you realize that, wow, well, a customer reported that they couldn't use an app and in a particular location, and yeah, while network speeds are getting better and more reliable, it's certainly not universal, right? So really think about who's using the app and where are they using this app. Are they going to always have reliable network connection? And if not, then you really need to design your app with that in mind. Native apps will obviously really look like native apps because they will look like all the other apps that people are downloading from the app stores. They have native controls, native user interface elements. They will work and feel like native apps. App Store marketing is another kind of big reason. I mean, people want to submit apps for distribution to the public through the app stores. There's a lot of searching that's already going on in these app stores, so it's a way to promote and market your app. If that's important to your app, that might be another consideration for doing a native app. And finally, but certainly not the least important, a native app, you would get access to new OS features and bug fixes much faster than you would with a hybrid app, right? Because when you have a hybrid app, you have to wait for bug fixes in the browser. You have to wait for browser to get fixed, or you'd have to wait for wrapper code, PhoneGap fixes, if a bug is in that code. So you have a lot more code in between your app and the operating system, and you have to wait on them. There was for example, with PhoneGap, there was a big issue when iOS 6 came out. It took a while for PhoneGap people to support it, right? So if you're relying on PhoneGap, you're going to be waiting on them to either expose new features or take care of fixing bugs for that platform. So keep that in mind. That's an important consideration for using native apps. So the problems, right? The native apps clearly offer the best performance, security, and so on. But what are the problems? Why are the challenges? Why isn't everybody building native apps? The problem is that you have to build an app for each platform. And you have to build an iOS app, Android app. If you're supporting Windows, there's a separate Windows app. And basically, it takes a lot more time, and therefore it will take a lot more money to build these apps. Secondly, is finding developers with these skills, right? I mean, it's if you look under on Monster.com, just type in mobile app developers. Look for Objective-C or Java developers. You see how many job openings exist. I mean, the supply of people capable of building native apps is significantly less than demand. So therefore, the salaries tend to be very high, and for many companies we work with are having a hard time attracting mobile developers. So that's definitely an issue. Third issue is retraining, right? Your learning curve is very steep. If you take your existing programmers that haven't built Objective-C or Java apps, and you're looking at anywhere from 6 to 9 months for people to become fairly proficient in being able to develop with these technologies. So that adds significant time. And then on top of that, once you build them, you're then dealing with, well, how long does it take to build native apps? And again, depending on, how you build them, what tools you're using. But, on the average, if you're, building using the SDKs, you're going to be looking at 4 to 6 months on the average to develop a native app, which is, not an insignificant amount of time. So when you take the development time plus the learning curve, you could see very quickly, why native app development is difficult for a lot of folks. So let's talk about how to speed up mobile app development. What can be done to speed things up? So if you haven't heard of this term, MEAP stands for Mobile Enterprise Application Platform. Mobile application platforms have been created in response to people basically trying to accelerate mobile app development, right? And if you choose a good MEAP, it should really give you a significant acceleration on the mobile app development, as well as reduce the skill level that's necessary to develop mobile apps. So let me talk about kind of what to look for in a mobile application enterprise application platform. So the very basic thing that it should give you is write once, run anywhere, right? You should be able to create one app and create it once, and MEAP should generate the code if it creates a native application, or generate the HTML5 JavaScript code. But in any case, you create one app, and it should create apps for all the platforms that you want to support. Second thing is, a good MEAP should not force you to use either a native or a hybrid approach. A good MEAP should give you the support to support both, whatever makes sense, whichever approach you want to use. And even if you want to mix and match, for example, Snappy MEAP allows you to take HTML, JavaScript code and embed it into a native app. So you can, wherever it makes sense, you can use HTML, JavaScript to extend Snappy platform with your own code, or reuse some code that you already have. And Snappy will take care of generating native code. So this way you really have the best of both worlds. It's not an either or, it's a mix. You can decide how much of a hybrid app you want and how much of a native app you want. You don't have to decide, between the two, right? A good MEAP should be easy to install and configure. It really should not require you to do those things. It should be SaaS based. You should be able to go online, register, and then begin building your apps without having to spend time installing, configuring, and figuring things out. A good MEAP should result in a lot less code, or no code at all, right? I mean, there's if you have to code, you should be looking for savings in code somewhere around 60 to 70%. I would say should be, on the average. And if you're using a MEAP like Snappy, which is a visual MEAP, you're not writing code at all. For the majority of your apps, you're building your apps visually. Okay. And finally, really a MEAP should not be asking you to learn another proprietary language. I mean, there are enough programming languages in the world, and it doesn't You should not be learning another proprietary language which has then no application anyplace else other than this MEEP, right? So if a MEEP should use a standard language like a JavaScript or native languages to the platforms, or it should be visual, right? But it should not require you to learn a proprietary language. So let me give you an example of what visual development looks like using Snappy. So in Snappy, you're not writing code at all. For the majority of apps, Snappy will automatically generate the code that you need. So whether it's native code for Java code or Objective-C code for native apps, or HTML5 code for kind of a HTML5 hybrid approach. So what you do in Snappy is you visually build app in the WYSIWYG editor. You build apps by dragging and dropping functionality on a platform neutral canvas. Okay, and then Snappy takes care of code generation. So you visually build your app using UI controls, but you do more than UI. You also drag and drop functional objects here. So for example, if I wanted to add a QR code scanner to my app, I just drag and drop the entire QR code scanner. I put it where I want it, and then I added the properties, and that's all I have to do. Now my app has an entire QR code scanner or an entire shopping cart. These are examples of how you can work in a visual environment at a much higher level of abstraction. When I want to see what I've built, I just hit save, and then I can immediately see my app run on any mobile device. Okay, it literally, you build, you save, you see it run. And not just me, members of my team can do the same thing. So it really facilitates kind of a collaborative development approach where you can begin showing the app to usability people or customers, start getting immediate feedback, and you could literally be making changes of this app on the fly, right? So when a customer says, hey, I don't want this OK button here, can we move it there? You can literally do that, hit save, and they see the changes. I mean, it's really cool. I would very much encourage you to try this out on snappy.com. It's a very neat way, very quick way of developing. You're not spending time in debugging. You're not debugging. You're basically building app and then you're seeing it immediately run. So that's kind of an example of visual development process. If you kind of look at what the flow of this looks like, you're working in the WYSIWYG editor, you're building your app. When you say I want to preview, all the code generation, all this stuff happens in the background. You don't need to worry about it as a developer. You immediately start seeing this app run, and you iterate until you really have it down, right? So this rapid development approach basically allows developers to save many months. What you would do as a developer by writing code, what would take months, you literally in Snappy can do in days. I mean, that's the level of programmer productivity enhancement that we're talking about. When you are done, Snappy has automated submission of the app. So you simply, answer a few questions, and Snappy takes care of submitting it to public app stores or private app store. Once you release the app and you want to update it, and you will be updating your mobile app a lot, much more so than desktop apps, because people still don't know what they want. You're going to be making changes to your mobile app even before it's released. I mean, it's a very iterative approach, very kind of agile development approach. So Snappy has a built-in and a capability, an updater capability, where you can literally make changes in the app and then publish them, and everybody who's using this app is getting a notification that there's a newer version available, and they can update immediately. I mean, that is really huge. It doesn't matter whether you're updating it on 5 devices, right, or 50,000 devices. I mean, you can instantly update your app for your users. It's really cool. The app that is created uh, uses a very scalable architecture. In fact, this is not, I'm using Snappy here as an example, but the same is true pretty much with any mobile architecture, scalable architecture. You have a front-end app, and then you have a back-end server, okay, which then makes access to corporate databases or web-based web-based services. Why is everybody choosing this type of an architecture? There are essentially a couple of really good reasons for why everybody uses this architecture. First of all, scalability, right? I mean, if you're building an app for 10 users, I guess it doesn't matter. But if you're going to build an app to support 50,000 users, and this app eventually needs to get data from, let's say, SAP. You're not going to build an app that will scale that has to make 50,000 connections into SAP platform. So you really need to have this intermediate layer. Another good reason is performance. I mean, there's a lot of code that you don't want to execute on every mobile device. Things like notification services, database services, location services, user access management, all of these types of things. It's best to take things that are heavy CPU intensive code and move it to the server where CPU is fast, not do it on a mobile device. I mean, while mobile devices have gotten faster, there's nowhere near the CPU power that you have on the server. So your performance will be so much better when you have this kind of a distributed architecture. And the last but not least, uh, with this kind of architecture, you have a lot less code to write. There's a lot more code reused. So all of these services that the server is performing are best done on the server once instead of having to write them individually for each platform, right? That makes no sense. So these are the slides I have. I encourage you to try out visual development of mobile apps at snappy.com. You can register, start building. There's no charge for building these apps. You only pay when you go to publish. So it's free to try. And I am going to switch over and see if there are any questions. Okay, so it doesn't look like there are any questions. So I thank you for your time today. If I missed something or if you have additional questions, feel free to email us at support@snappy.com or sales@snappy.com, and we'll be glad to help. Oh, I see. Okay, I see a question. So hang on, let me try to get to it. Can your Meep work with databases and Amazon Web Services? Yes, it can. It works with databases by using RESTful interfaces. So the way you would access databases from Snappy in Amazon would be basically by creating a connector, an XML connector. There's no code that you have to write. You basically create an XML connector, which is a document that describes how the app should interact with a web service, what kind of functionality is available there. And once you create this document, you upload it to Snappy, and now your Snappy app can interface with these web services. So that's how it can be done, and it doesn't matter where the database is or it's where it resides. Basically, it's a RESTful interface web services has gotten to be a pretty standard way that you can interface with systems online. Other questions? Okay, I guess there are no other questions. I thank everybody for your time today, and hope to be working with you guys in the future. Have a good one.